Hi, I am Siddharth. I am here to tell about the CO8 concept video topic assembly language. First of all, what is an assembly language? An assembly language is also known as assembler language, is a type of low-level programming language that is intended to communicate directly with a computer's hardware. Unlikely mission language, which consists of binary and hexadecimal characters. Assembly language are designed to be readable by humans. Low-level programming languages such as assembly language are a necessary bridge between the underlying hardware of a computer and the higher level programming language such as Python or JavaScript, in which modern software programs are written. Here, an assembly language is a type of programming language that translate high level languages into mission level languages. It is a necessary bridge between software programs and their underlying hardware platforms. Today, assemble languages are rarely written directly, although they are still used in some niche applications such as when performance requirements are particularly high. Here, here we can see how assembly languages work. Fundamentally, the most basic instruction executed by a computer are binary codes consisting of ones and zeros. Those codes are directly translated into on and off states of electricity moving through computers' physical circuits. In essence, these simple codes form the basics of machine language, the most fundamental variety of programming language. Of course, no human would be able to construct modern software programs by explicitly programming ones and zeros. Instead, human programmers must rely on various layers of abstraction that can allow themselves to articulate their commands in a format that is more intuitive to humans. Specifically, modern programmers issue commands in so-called high-level languages, which utilize intuitive syntax such as whole English words and sentences, as well as logical operators such as and, or, and else that are familiar to everyday usage. Ultimately, however, these high-level commands need to be translated into machine language rather than doing so manually. Programmers rely on assembly languages whose purpose is to automatically translate between these high level and low level languages. The first assembly languages were developed in 1940s, and although modern programmers spend very little time dealing with assembly languages, they nevertheless remain essential to, to the overall functioning of a computer. Here we can see the assembly language syntax. Assembly language uses as mnemonic to present example each low level mission instruction or OP code, each directive, typically also each architectural register, flag, etc. Some of the mnemonics may be built in and some user defined. Many operations require one or more operands in order to perform a complete instruction. Most assemblers permit named constants, registers, and label for program and memory locations, and can calculate expressions for operands. Thus, programmers are fed from tedious repetitive calculations, and assembler programs are much more readable than machine code. Depending on the architecture, These elements may also be combined for specific instructions or addressing modes using offsets or other data as well as fixed addresses. Many assemblers offer additional mechanisms to facilitate program development, to control assembly process, and to aid debugging. First of all, what is an assembler? An assembler program creates object code by translating combinations of mnemonics and syntax for operations and addressing modes into their numerical equivalents. This representation typically includes an operation code, means OP code, as well as other control bits and data. The assembler also calculates constant expressions and resolves symbolic names for the memory locations and other entities. The use of the symbolic references is a key feature of assemblers, saving tedious calculations and manual address updates after program modifications. Most assemblers also include macro facilities for performing textual substitution. Example, to generate common short sequences of instructions as inline instead of called subroutines. Some assemblers may also be able to perform some simple type of instruction set specific optimizations. On, on concrete example of this may be obtuse assemblers from various vendors called jump sizing. Most of them are able to perform jump instruction replacements, which is long jumps replaced by short or relative jumps in any number of passes on request. Other may even do simple rearrangement or insertion of instructions, such as some assemblers for RISC architects that can be helpful optimize a sensible instruction scheduling to exploit the CPU pipeline as efficiently as possible. Assemblers has been available since the 1950s as the first step above mission language and before high level programming language such as Fortran, Algol, COBOL, and Lisp. There have there have also been several classes of translators and semi-automatic code generators with properties similar to both assembly and high-level languages, with speed code as perhaps one of the better known examples. There, there may be several assemblers with different syntax for a particular CPU or instruction set architecture. For instance, an instruction to add memory data to register a family processor might be add in original ideal syntax, whereas this would be written in AT&T syntax used by GNU assembler. Despite despite different appearances, different syntactic forms generally generate the same numeric mission code. A single assembler may also have different modes in order to support variations in syntactic forms as well as their exact semantic interpreters, such as FASM syntax, TASM syntax, ideal mode, etc. in the special case of assembly programming. There, here we there are number of passes in assembler. There are two types of assembler based on how many passes through the source code are needed, which are how many times the assembler needs to source to produce the object file. The first one is 1 plus assembler. Go through the source code once. Any symbol used before it is defined will require errata at the end of the object or code, or at least no earlier than the point where the symbol is defined, telling the linker or the loader to go back or overwrite a placeholder which has been left where as the it undefined symbol was used. And the second one is the multipass assembler. Create a table with all symbols and their values in the first passes. Then use the table in later passes to generate code. We can see the real world example of the assembly language. Today, assembly languages remain the subject of study by computer science students in order to help them understand how modern software relates to its underlying hardware platforms. In some cases, programmers must continue to write in assembly language, such as when the demands or performance are especially high, or when the hardware in question is incompatible with any current high level languages. One such example, this is relevant to finance or the high frequency trading platforms used by some financial firms. In this marketplace, the speed and accuracy of the transaction is of paramount importance in order for the HFT trading strategies to prove profitable. Therefore, in order to gain an edge against their competitors, some HMT firms have written their trading software directly in assembly languages, thereby making it unnecessary to wait for commands from high-level languages to be translated into machine language. By this, I am ending my session. Thank you.